Hi, I'm Steve Conway with IDC, and I'm here today with Garth Gibson, co-founder and chief scientist of Panasas, and we're going to talk about storage trends in HPC. So, Garth, welcome.
Welcome.
First question is kind of a general one. You talk with a lot of people in the HPC community and around the world. What's missing? What way do they want storage to evolve in HPC?
Well, you know, there's different contingents to all of these questions. The base group that I run into all the time is still trying to figure out how they're going to soak up all of that big data and turn it into something valuable for their organization. And some take that in the direction of how can I afford to keep everything that comes by. And some take it in the direction of how can I develop and install and deploy new tools that can extract information. And some take it in the direction of how is that going to be managed? I can't possibly do it myself. And I see all of these. The academic side of the world are probably most interested in how we're going to better understand and better extract information. And exascale, of course, is on the conversations these days, and how can we, the problem that has happened there is that storage systems take a long time to build. They're largely synchronous with people's expectations, and they have to serve all of the applications at the same time, possibly, and that hasn't scaled as fast as computers scale. And so we have done layering partitions. I mean, we've developed the object model that is pretty much in most of the major installations, separating it from the metadata model. And people are talking about, well, what do we need? The metadata model is still too synchronous. What are we going to do to separate that out? But for the most part, I think people are just trying to figure out how they don't have to throw away data. So they're very concerned about speed, cost, manageability.
What about buyer sophistication? Historically, the focus in HPC has been heavily on the compute side. Have buyers become more sophisticated in recent years about buying storage?
Well, there certainly are buyers that are very aware of their data. And so there are instances in the media space, in the life sciences space, where the data itself is really very important to them. And they are buying computers to hold their data and to process their data. But I'd say that your core HPC people live and breathe cycles.
Okay.
And I don't expect that to change. That's generational.
Okay. Storage hierarchies, they seem to be getting deeper.
Oh, yeah.
Where do you see that going?
Flash is here to stay. Flash is the answer to speed for storage is Flash. The reliability, integrity, and the variation in products in Flash has taken off. That's forcing another tier, maybe two tiers into the hierarchy. I think the more interesting question here is whether or not we're going to do it all over again. Is there another solid state technology that will make Flash more interesting? And so far the answer is no. Okay. But there certainly are a lot of technologies that are exciting, from PCM to spintronics to memristors. They're all very interesting.
And what kind of an impact do you see from NVRAM?
You know, the most important part about this is that we're going to make managing the power fail issues in computers simpler. They won't necessarily require the big UPS in the installation. You'll have the ability to have your write buffers battery backed up with Flash behind it, for example, as part of the NVRAM infrastructure. The tantalizing notion is to rewrite the software and hardware, or rewrite the software everywhere to be present and persistent all the time. And this is intriguing. I've seen some interesting experiments with that. It's pretty hard. It's plumbing. It's rewriting all the software. But I think what will happen for the most part, the most important thing will be that power fail will just stop being important. I mean, it'll be so important that we won't question it. It'll just always be there.
Okay. We see in our tracking of the market that data-intensive computing, both on the modeling and simulation side and also on the analytics side, is growing faster than the market as a whole. Are you seeing that also?
Analytics in all of its variations is just critical. I mean, companies have figured out how to make money from advertising. They've figured out how to make money from optimizing for their customers. So they're driving the analytics on the physical sensors and on the transaction sensors. The academic world has gotten very excited about technologies for making that more efficient. And the products are trying to find better ways to integrate their solutions into analytics. Yeah, I think that this is a gigantic move. And I think we're just barely started.
And how important is POSIX compliance for the future?
We all break POSIX compliance when it's necessary. POSIX, the most important thing about POSIX is that just about every junior programmer, outcoming student has a notion of what a file system is and how it should behave. And if you had to put one label on that, it would be POSIX. In fact, they're not strict. They don't know the semantics of POSIX very closely. They don't depend on the semantics of POSIX very closely. But they're well aware what it loosely is, and it loosely describes their experience, and that's what they write their programs for. So when you make big changes from POSIX, you risk that your programmers just are not prepared and don't have the depth of experience to know that they shouldn't take advantage of specific things, or it won't be portable. So I think that things like S3 completely blew off on not just POSIX, but the whole hierarchical storage model.
Yes.
And I think that that's hard to swallow. I think you spend a lot of time when you move your application from the data center to the cloud dealing with the storage model. And I think that's awkward, and those are the big changes away from POSIX. But the little changes from POSIX, they've happened, they're going to continue to happen. I think that the more pertinent question is when you start to look at structured data again, and you've got the NoSQL versus the new SQL, I think that a lot of the NoSQL ideas were more convenience than necessity, and the new SQL, which is essentially much more transactional join structures, they are making a comeback at the moment, and we will not be abandoning our traditional relational databases anytime soon.
Even though they're going to be around and going to remain very important, do you also see growth in methodologies like graph analytics, creating new opportunities for storage?
Absolutely. And in fact, I wouldn't for the moment suggest that analytics is database. I mean, this is a very, even warehousing versus OLAP versus OLTP. That's too narrow thinking. This thing is exploding and going in all directions. We're going to optimize for everything important. And I think you're going to see like what you call the graph processing approach. This is essentially sparse data structures, and how can you process with the same kind of efficiency that we've had in the past things which are mostly empty. And there's a fair bit of history, a fair bit of technology in place around this. The thing that makes analytics so interesting is convergence. Mm-hmm. So the algorithm is taking an approximation of what's going on, and then they're converging by search strategies to a solution which is a better fit for the model they've got postulated. And that is amazingly interesting. It really gives us a high degree of freedom to tolerate error and still get the right answer. Whereas physical simulation, we've never had that degree of freedom.
Yeah, well, speaking of error, the systems on average are becoming larger, they're becoming more complex. How do you deal with the challenges that presents for both performance and reliability?
Well, the core thing about reliability is that the data is getting huge, but it's also getting more and more important. It's too big to recompute. It's too valuable to recompute. You may not have the physical source. You may have a very limited ability to capture everything that you want. So data reliability, we're going to put more layers in it. We're going to be doing a lot more checking of memories because memory errors are becoming well, not really more likely, more that we have such a large amount of memory that we're more likely to see memory errors. But in the storage world, we got a big jump on this. We had unreliable devices, not unreliable, just they're wonderful. They're 1 million hours mean time to failure. But that's not that long when you put a whole large number of them down. And so we have the good technologies in the Panasas products. We went to RAID 6 Plus, and the Plus is the important part. The important part of this is, we call it Plus, but fundamentally what it means is an architecture to provide service even in the face of an unacceptably large number of failures. So when we experience more failures than the code, like a RAID 6 would tolerate, we'll lose some access to a few things, but we'll continue to provide access to the ability to capture information and to the vast majority of the information and to its organizational structure. And that kind of always trying hard to be available, not just giving up when you hit your threshold of failures, I think is essential, because the data structures and the storage environments are getting way too big to ever tolerate just stop conditions.
I guess it's no secret that areal densities have been progressing much faster than access densities. Is anything to be done about that?
Yeah, it's called flash. No, I mean, there's no question that the areal density in disks is about cost, and that's essential, and that in fact what this change, the introduction of the flash technology has done, has caused us to refocus on what disks do really well. We drive that areal density to large numbers, lowers the cost per byte, and we're not going to get our seeks per second from the disk. We're going to get our seeks per second from hot data, and hot data is going to fit into the next tier, and the next tier is mostly going to be flash. I mean, that's what our products have been doing for 5 years now, and it's just it's the only real way to organize something that is going to give you both good dollar per gigabyte and fabulous performance.
Okay. And the last question is, we've talked a little bit here about the increasing complexity of the storage systems. How much of a factor do you think intelligence and automation in the software is going to help to deal with this management challenge?
So automation, tiering, management infrastructure, ease of expansion, ease of installation, these are the things that differentiate a science project from a service that's there and you don't pay much attention to it because it's what you want and it's what you need. I think that manageability isn't going away, especially as we scale the amount of equipment. It's more important all the time. Intelligence is an interesting word. What usually intelligence means to most of our vendors is that we redraw the API in some interesting way in the partitioning of the system. So if we redraw the API in some interesting way, then we can do innovation on an API we didn't used to, and that can solve a problem. So that'll be perceived as intelligence in a new place. And so I think it's it's kind of squishy what that really means. But I think that there has been a rapid growth of acceptable APIs. Things like the object store world and the open source environments that have evolved around it have produced a whole lot different ways of processing the data. NoSQL and NewSQL being examples of that. I think different APIs are going to continue to happen. I think the core APIs, the file API that we think most users are comfortable with isn't going away. It's providing phenomenal value. It needs to be faster. It needs to deal with a lot more small things. But you'll see specializations of it. The key value store abstraction is a specialization of metadata processing in file systems. And there's very aggressive performance numbers in that, dealing with very specific solutions. And I think that those type of innovations, now that we've got a freedom to do new APIs, we're going to see a lot of innovation.
Okay, well, thank you for a very interesting discussion. Steve Conway with IDC, and we've been talking today with Garth Gibson, who is co-founder, chief scientist of Panasas.